Bismillahirrahmanirrahim. Okay, now we shall talk about one of the most important concepts in science. How do we study things? And this particular thing called the scientific method. Alright. Speaking of worms, why do worms come out when it rains? Why do they come out? You know that? They get wet. If they didn't come out, they would suffocate. Under soil is not like cement. It's not like every single part of it is. You know what I'm saying? Soil has a lot of air in it. That's why you step on it and it goes down by a lot, right? So worms, they breathe. They get the oxygen they need from their skin. They absorb it. You follow? But when it rains, they're like, there's all those pores where air used to be are gone. All water, right? So they're like drowning. They're drowning underground. So they come up there so they can breathe. That's why worms come. Now, so why do earthworms leave their burrows when it rains? Because they need to breathe. See? This is the blood vessels. They're very close to the surface there of the body, like this. Yeah? And water does not have as much air as does air. That's why they come out. Now you know. Now look. This is Abu Ali al-Hasan bin Hayth. You know who that is. You've probably heard. Mufti Azim could probably tell you a few things about him. He's credited with creating this scientific method by most authorities, most Western scholars. Ibn Haytham, he was from Iraq. Yes? So he was a Muslim scholar who's considered to be, by many, I should say, the father of modern science, of modern scientific methodology. Why? Because of one principle. One important principle. Very important principle. We're talking about how we study science, how we study biology. One important principle, and that is his emphasis on experimental data. Right? Experimental data and reproducibility of the results. You have to get data, but you have to reproduce it. Do the same experiment over and over and over again. So Ibn Haytham is considered to be the father of the scientific method. Should we know about it? You bet we should know. We should know it backwards and forwards. Emphasis in data and reproducibility of stuff. Okay? The scientific method is as follows. You can describe it in many different ways, in many different steps. But the first step to all science is observation. It's like, you've seen worms on the road, on the street after it rains. Yes? You wonder why they come up on the ground? I don't know. I mean, when I was 19, I don't think I did. You understand? But you have to have a certain natural curiosity. The same thing that Holmes said to Watson. You ever count the steps, right? You wouldn't. You follow? So you have to have a certain curiosity. You have to ask questions. Why is it that? Right? Why do leaves fall in wintertime? Why do some leaves fall and others don't? Why does the day shorten in winter? Yes? You have to have this certain curiosity. It's more than seeing, right? Seeing is not observing. From observations, then you produce a question. Then you make a question. Okay, so here I'm noticing. First thing you have to do is you have to actually notice that there are worms on the street. If you don't notice, I mean, you're not even going to ask the question. So you have to be aware. You have to look at the inna. Allah says, إن في خلق السماوات والأرض واختلاف الليل والنهار والفلك التي تجري في البحر لآيات. Allah tells us to observe. No wonder Ibn Haytham is a father of the scientific method, because he's following the teachings of the Quran. Allah encourages us to look at the environment, phases of the moon. Why? Why do moon has phases? Why is it that the moon, you never see the other side of the moon? Even though the moon rotates. You know the moon does not rotate, it goes like this. But you never see the other side. So you must observe. Okay, I'm taking a detour. Side detour. Right? If you're not careful, our society will numb, will kill your ability to observe. It will numb it, so you won't be able to observe. Yeah? One, because Allah says, Inna fi khalqis samawati wal ardi. Yeah? Do you understand? And the shaitan is after us. Number two, it won't give you a chance to observe. Like you'll be so much garbage there that you won't be able to experience life on your own. Yes? So you have to pay attention. Allah gave that ayah. That's a beautiful ayah. It's a long ayah, right? Pretty reasonably long, like 5 lines, right? Right? And it will take you some time to actually put that into practice. But who are you going to do that if you Google there and you're watching video playing PlayStation 4 or whatever, you know? If you're not careful, this society will eliminate, will obliterate, destroy your ability to observe. But be careful, mind yourself, because it's beautiful. It's beautiful. So you observe, and then you ask the question, why? Why does this happen? And then, what do you do next? Hypothesis. You make a conjecture. What's a hypothesis? Your best guess. Right? Your best guess. And then what do? You experiment. You construct an experiment. You construct an experiment to see if your hypothesis is true. Correct? And then you get results. And then you conclude. Do you stop? Right? No. You repeat. And that's the scientific method. You understand? That repeat is in capitals. Notice. The repeat is in capital because that is the heart of the scientific method. Right? Heart. Right. Now, so you do an experiment, right? You create a hypothesis. Okay, this happens. You create an experiment, and you get results, right? Right? And then you get results, and then you propose a theory, right? And you have a theory, correct? Yes? 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 Okay, observe, you question, you make a hypothesis, you do an experiment, you get a result, and then you formulate a theory, right? Right? Wrong! Very important. Very important. One experiment is insufficient to make a theory. One experiment is what? One experiment. That's all it is. You have to have hundreds of experiments to be able to formulate a theory. The word theory in science is not something you can throw here and there. It's like, do you understand? A theory has some weight behind it. So you have to have a lot of evidence before you can say it is a theory. So when somebody says the theory of evolution, it's not just he came up with it one day and just wrote one paper and there it is. He collected data for years and years. He was Darwin, super nerd of nerds. Yeah, he had so much data, right? He had to truncate his book. After he's truncated, it was like this big. Right? And then it has to be repeated over and over. So you can't be dismissive of the theory of evolution, for example, because it's just a theory. It is just a theory. Theories have lasted for hundreds of years, and they were proven wrong. Yes? They were proven wrong. But you can't be casual about it. You have to be vigorous. You have to be intellectually vigorous. You follow what I'm saying? Okay. So, does one experiment make a theory? Everybody? Do we have a consensus on that? One experiment make a theory? No. It's not that easy. You follow? Now, look at this. Law of gravity. Why isn't it like a theory of gravity? There's a difference between the two. Law in science is like boatloads of evidence. So much evidence that you can't even, it's unfathomable evidence. Because why? Another experiment. Do you understand? So a law is much higher than a theory. You follow? Much higher than a theory. So if the theory is so vigorous, and a law, let me say the law of gravity, for example, right? They have a lot of weight in science. Does that make sense? Okay. So this is the scientific method. Get it? Very important. So a lot of people know it. They memorize it. Hypothesis, experiment, results, conclusion, repeat. But the nuances to the understanding of the scientific method. Right? Yes or no? Yes? That's what you must understand. Ready for an example? Take your example. All right, this is an example from your book. I'm not just coming up with it. All right, so brown tree snake was accidentally introduced to Guam. Guam has a Guam. Tiny thing. So, was introduced to Guam in 1940s. Okay? So, how, I don't know, maybe they're carrying it a pet or, okay? So, in 1965, apparently, a local newspaper, they commented, snake might be beneficial to the island because it fed on rats, mice, and other rodents. A good thing to have the snake. Thumbs up to snake, although snakes doesn't have thumbs up. Right? Thumbs up to snake. Then a biologist was there, and then he noticed observation. Remember that? First step of the scientific, you have to observe. Right? He observed something ordinary. He said, I've been here several years ago. Something very different about it. Something different. And then realized the forest was quieter. Lots of birds were missing. Why? Because the tree, and he proposed, why? That was an observation. He proposed a hypothesis. Why? Observation, question, hypothesis. Why? He said, oh, I bet it is the snakes that are doing it. That's the hypothesis. Then you have to create an experiment, an ingenious experiment. You have to find every snake, tag it. You understand? You follow. But if you don't observe, you never come up with anything. Right? So you have to be aware of your environment. So when you walk outside, you have to notice what you're walking around, what's around you. Right? That's the quality of a scientist. So he came up with the hypothesis snakes were eating the birds. Okay. Now, then if you come up with the hypothesis, you have to come up with an experiment. All right. You must know this. You must know this, like if I ever call you up like middle of the night, like 3:30. Okay. What's the control experiment? Like that. You have to control experiment. This is what it is. You have to know this. If you go to college not knowing what a control experiment is, you fail high school. We don't want you to fail high school, so you must know what a control experiment is. Yes? Okay. There are all kinds of experiment. One example is observational studies. You just observe what's going on, right? And just write about it. But the best experiment in science is called a controlled experiment. Control experiment, you're controlling everything, right? Like control freak. So it's an investigation designed to test the hypothesis. Hypothesis. Here's a hypothesis. Fertilizers help plant growth. True, false? Yes? You think that's true? Fertilizers help plant grow? You go to Home Depot or Menards. You go to the fertilizer section. It says, plant will grow like this. Yes? How do you know they're not just ripping you off? Yes? How do you know? The claim is what? Fertilizers help plant growth. Maybe they're just ripping you off. So you have to do an experiment. It's always very good to place your hypothesis in a... What kind of statement is this? If then... Huh? MashaAllah. What is it? Conditional statement. Good job. I'm going to give you 3,000 extra credit points for that. Conditional statement. A conditional statement is an if-then statement. Because it helps you think properly. Conditional statement. Now, same thing says, fertilizer help plant growth. Can be restated like this. If a plant receives fertilizer, then it grows better. You understand? That's a conditional statement. An if-then statement is called, what's up? What is it called? Conditional. The first part is the condition, right? If you give plant fertilizer, then it's going to grow better, silly. Yes? So that's a conditional statement, if-then statement. Okay? It's much better to say a statement like that. Okay, now, To test this out, you do experiment. The best experiment is controlled. In the best experiment, you have 3 groups. Yes? No. You have 2 groups. You have 2 groups. One is called the control group. The other one is the experimental group or the variable group. These 2 groups are identical. They are identical in every way, except one thing. And that thing that's different between the 2 is the thing that you're testing. Do you understand? So the control group and the variable or the experimental group are identical, except the variable group, the experiment one, has one difference, and that difference is the difference you're testing. Does that make sense? So, for example, if you wanted to do this experiment, you have to have plants, right? Okay, plants are in soil, right? Right? The soil quality between the 2 groups has to be the same. What if one soil is better than the other soil? Is that a fair experiment? No. So the soil quality has to be the same. The amount of water they receive must be the same. The amount of sunlight they receive must be the same. The direction of sunlight has to be the same. The duration of sunlight has to be the same. You follow? And the plants have to be the same. You can't pick roses and tomatoes and see fertilizer here, fertilizer, see which one grows better. Yeah? They have to be identical in every way. Except one will get fertilizer and the other will not get fertilizer. So the difference between these 2 groups, you see the difference? Same soil, same water, same sunlight, same everything. And same attention. You talk to the plants. Hello, plants, how are you doing today? Some people talk to the plants. Hello. You're silly. The plant cried. Remember when the member of the messenger of Allah's son was made? The plant cried. But anyway, some people do talk to plants. So, you have to give them equal attention. Does that make sense? And these are 2 terms. You're almost finished, don't worry. 2 terms. Now, independent variable, dependent variable. If you put your question in if-then statement, this becomes very easy to identify. Okay? If a plant receives fertilizer, that's the independent variable. Okay? Fertilizer is the independent variable. Then it grows better. That's the dependent variable. Right? Because the growth is dependent on the fertilizer. If you put your question in a conditional state form, the first part, hypothesis part, gives you the independent variable. If a plant receives fertilizer, therefore fertilizer is independent variable, plant grows better. Growth is the dependent variable. Does that make sense? If you take calcium, your chances of getting osteoporosis are less. Independent variable, calcium. Dependent variable, whether somebody has osteoporosis or not. You understand that? Okay. And then, once you do the experiment, you come to the results, and you conclude the results. And then you reproduce the results. Okay. Why reproduce the results? Why should you redo the experiment? Right? Why? Right? You need to reproduce the experiment because maybe you weigh something and your weigh scale was broken that day. Yes? You need to reproduce the experiment because the fertilizer you put was near expiration date. And that's why it didn't work so well. And you blame the company and write a letter. Yeah? You understand? Maybe also somebody else needs to reproduce the experiment. Somebody else needs to reproduce the experiment. A scientific paper is worthless if you don't write in it in a section called methods, telling people how to reproduce the experiment. Who came up with that? Yeah, we did. Understand this? You have to tell people how to reproduce the experiment because reproducibility is the heart of the scientific method. You understand? So if somebody writes a paper and they said this is the experiment we did and this is the result, and they didn't tell them how you did the experiment, that's a worthless paper. You throw it away. You don't publish it. Except in a cheap journal, I'm saying. Yeah? So you have to be able to reproduce it. Maybe your experiment was bogus. Maybe somebody else could do it better. Yeah? Okay. And then you repeat it. You can't always collect data. Okay? Like Darwin couldn't go do experiments on evolution because evolution occurs on millions of years. How are you going to do an experiment? I'll come back after a million years over here. No, we can't do that, right? Right? So some experiments are qualitative, means you can't collect data. It's observation. That's what Darwin did. It's weak evidence, so you have to collect a lot of evidence. That's what he did. Does that make sense? Quantitative experiments where you have numerical data. Qualitative experiments is when you just descriptive data. Does that make sense? Do you understand the difference? For example, this is how many paramecium, these little organisms over here, based on temperature. This is what kind of experiment? Quantitative or qualitative? Quantitative. You're collecting data. They like this temperature, see? It's too hot, they die. Too cold, not so good. Yeah? This is examples of a quantitative. The best, great example of qualitative data is Darwin. Break time. Inshallah, we'll continue with this in our second lecture on positive. Until then, assalamu alaikum.